Hello viewers, today I want us to go through this concept of trigonometric ratios and identities and how we can use them to solve real life problems. So before we do anything, I want us to use what we call unit circle. Unit circle is a circle whose radius is 1 unit. As you can see, I have labeled here. And inside this circle, I have drawn two axes, the y-axis and the x-axis. Y-axis and x-axis. They intersect at the origin, and I've drawn a right-angled triangle, you can see. So the hypotenuse of this triangle is 1 unit. So from this point to this point, from this point to this point of this triangle, I want to call it change in x values. Change in x values. From this point to this point, I want to call it change in y values. Now, we know very well that the sine of an angle is given by opposite side of the triangle divided by the hypotenuse of the triangle. We are using the same triangle. If this angle is here, let's say we have angle theta here. This side is adjacent to this angle, and this side here is opposite to this angle, and this side here is the hypotenuse of this triangle. So sine of this angle is given by opposite side divided by hypotenuse. We also know that cosine of this angle is given by adjacent side divided by hypotenuse. We also know that the tangent of this angle is given by opposite divided by adjacent sides. We need to have that knowledge first. So from that we can say that sine of this angle is given by opposite, which is change in y, over hypotenuse, which is 1 unit. And that one tells you that sine of theta is just change in y values. And then cosine of this angle is given by adjacent side, which is change in x values, divided by hypotenuse, which is 1 unit. That one tells you that cosine of theta is just change in x values. And then lastly, we have tangent of this angle given by opposite side, which is change in y values, over adjacent, which is change in x values. So what does that one tell you? That tangent of theta is given by change in y values is sine of theta, change in x values, that is cosine of theta. And this is one of the trigonometric identities that we're going to use in our calculations. Tangent of theta is given by the ratio of sine and cosine. Sine of theta divided by cosine of theta. This is one of the trigonometric identities that we need to remember. Apart from that, we also have another thing that we need to derive here. Using Pythagoras theorem, we know that if we have a right-angled triangle like this is C, this is A, this is B, Pythagoras theorem says that C squared is given by A squared plus B squared. Now, assuming this triangle is this, our C squared is 1 squared. That is our C squared equals to A squared, which is changing Y squared plus B squared, that is changing X squared. Let us do the necessary substitution. 1 squared is just 1. Changing Y squared is, there is a point I've told you that changing Y is sine of theta. And I've also told you that changing X is cosine of theta. So let us just do this substitution here. So 1 equals to sine squared of theta plus cosine squared of theta. You can reorganize this one to look this way. Sine of theta, sine squared of theta plus cosine squared of theta equals 1. And this is another very important trigonometric identity that we are going to use along